Copyright 2015 Math Diagnostics and Intervention, all rights reserved. We're going to teach how to add fractions. And one of the things to remember about teaching students how to add fractions is that any method of adding fractions that does not help students solve the addition of a rational expression like the one on the screen now is essentially a waste of time. So I'm going to go through how to teach students how to add fractions quickly and then use that same method to add the rational expression that we have here. Suppose we wanted to teach students how to add fractions 5 over 42 and 7 over 60. Well, the first thing we need to do is we need to find the greatest common factor and the least common multiple. And the way I teach that is I have students prime factor 42, and if you want to use a factor tree to do this, that's fine, you can do that. I prefer the factor ladders. I just find students generally have more success with factor ladders. So we prime factor the numbers. And I'm going to do this quickly because, again, this video is designed mostly for teachers. But we go through and we have our prime factorizations. So the next thing we do is we find the greatest common factor. What do these two factor trees or factor ladders have in common? Well, they have a 2 in common. What else do they have in common? They have a 3 in common. There's nothing else in common. So the greatest common factor is 2 times 3, which is 6. Now, the least common multiple will be the greatest common factor times everything else. So in this case, it's the greatest common factor times the things that did not get circled. So it's going to be the greatest common factor times 7 times 2 times 5. And the greatest common factor was 6, so that's 6 times 7 times 2 times 5, which is equal to 420. So that takes care of how to find the least common multiple, or the first common multiple. Now, how do we use this to help us find, to add the fractions? Well, 42 has everything that it's in its prime factor tree. What it needs are the things that were not circled in the other number. So what 42 needs the 5 and the 2. So 42 becomes 5 over 42 times 10 over 10 plus, and then what does the 60 need? Well, the 60 has everything it's in its prime factor tree, or its prime factor ladder. It needs the things that are in the other factor that are not circled, the other prime factorizations that are not circled. It needs 7. So we're going to multiply that 7 over 60 by 7 over 7. When we do so, we end up with 50 over 420 plus 49 over 420, and we end up with 99 over 420. Now that's not in lowest terms. They have a 3 in common, but for now we'll just leave it like this, and we won't worry about writing the fraction in lowest terms. How does this help us with the original problem that we saw here? Well, first thing we do is we factor our denominator, and our denominator on the left factors as x plus 1 times x plus 2. The denominator on the right factors as x plus 1 times x plus 3. What do they have in common? They have in common x plus 1. So we circle the x plus 1s. So the greatest common factor is x plus 1. Okay, what does the x over x squared plus 3x plus 2 need? It needs what's not circled in the other factor. So it needs x plus 3. So that's going to be x over x plus 1 times x plus 2. And we're going to multiply that by x plus 3 over x plus 3. And our x minus 2 over x plus 1 times x plus 3 needs what's not circled in the other prime factorization, which is x plus 2. Okay, so now we have x squared plus 3x plus x squared minus 4 over x plus 1 times x plus 2 times x plus 3, which becomes 2x squared plus 3x minus 4 over x plus 1 times x plus 2 times x plus 3. So once again, let's review this. When we're teaching students how to add fractions, we prime factor our denominators and we find the greatest common factor, and then the least common multiple is the greatest common factor times everything that did not participate in the greatest common factor. So in our case here, our greatest common factor was 6, and we had the 7, the 2, and the 5 that did not participate. Multiply that all together, and we find that our least common multiple is 420. We need to multiply each fraction by what it did not have, or by what was not circled in the other prime factorization. 42 needed 5 times 2, and 60 needed the 7. If we use this method and we use it correctly, it helps us solve the addition of rational expressions this way. Good luck.